So for today, it's just solving again. How do you know when you're done? When the x is alone. Here is a typical question where the x is in the argument spot. Now, a couple of reminders about that x that's in the argument spot. Number one, both the base and the argument, here's the base, here's the argument, they have to stay positive. Do you get if you got an answer that came out negative, that then when you put it here, it wouldn't be possible? That would be called an extraneous answer. That's going to happen. You're going to solve these. You're going to sometimes get an answer that's negative, and you got to be able to go, oh, wait, there were two answers, but this one's negative, so my argument can't be negative, so I got to rule it out. You've seen that before on other tests. So here's why that happens. You have a problem like this, and hopefully you're smart enough to remember you got to set it equal to 0. X squared plus 6x minus 7 equals 0. Then you got to factor it. I know you know how to factor by now. Plus and a minus because this is negative. And then this is positive 6x. I'll make this one bigger. And there we go. And then I get my two answers. X equals negative 7 and x equals 1. And do you get that that one's probably extraneous? Because this problem would have come from a log problem. Let's say I did this, plus log base 3 of x minus 1. Just for an example, you would have had this kind of a log problem, and all of a sudden they're all factored and they look like this, and you've solved it, and you forget that that one is extraneous. All right, so moral of the story, watch out for that. Don't forget factoring. It's been a thing since the beginning of the year. It's going to happen again. And exponents. You got to be good at things like, I know everybody knows x squareds, but do you know what cubed is 8? It's 2. Do you know that you can make those negative? Like negative 2 to the third is negative 8? Okay, you can't do that with squareds though. So when you're down to a squared, you can't say, oh, I'm going to make it this negative. That won't work. There's no way to do that. There's no solution to that because you're going to go square root, and you're square rooting a negative, and that doesn't exist. But when they're cube roots, that's possible, see? Because if something's to the third, that's fine. The negative just multiplies by 3 negatives, and you get a negative answer. All right. So there's some previews. Go to slide 2 of this. Take a look at that. And I don't see a base, and that's the first thing you should fix. Spencer, what's the base on ln? E. Good. So this is really instant rewrite time. Log base e x to the 4th equals 8. You know why that e is so important? Because the next step is rewriting it as this to the this equals that. And what if there was no this? You know what I mean? Like you can't rewrite the thing if you don't have a base. So you got to start by writing ln's as log base e's. And then it's e to the 8th equals x to the 4th. And I know that gets confusing because it looks like there's two variables. There's not. Riker, which one's actually the variable? Yeah. So if you're going to solve, you want to get the x alone, not the e. So I can put this to the 4th? No. To the negative 4th? No. 1/4. And then I just did the 4th root. Do you remember that deal where you just did a square root on both sides? Technically a 4th root on both sides. And that's got 2 answers. So let's finish it. But this, I just did the square root of a variable, so it's the absolute value of x. Man, this class is complicated, but hey, you could have signed up for FST and life would have been much easier. Even root, absolute value. It's like this. Just a quick reminder. If you did square root here and square root here, its absolute value of x is 4. That gives you 2 answers, 4 and negative 4. Okay, so this is an absolute value of x. And this is, wait a minute, what's this? That means I am still dismayed at how many kids think you multiply the top and the bottom by 8. No, you don't. Which one do you multiply by 8, the top or the bottom? The top. So it's 8/4, which is 2. So it's e squared. And then how do you get this thing out of the absolute value jail? You break it into 2 answers. You get negative e squared and e squared. Those are your two answers. They're different? Yes, they are. Now, I know you might be thinking, but if I squared negative e, it's going to come out positive. Nope. If there's parentheses anywhere on this, it would be here. That negative is on the outside. So you truly have the opposite of that. Okay. Whew. That was complicated. But if I look back at my original problem, is there a chance that my x value being negative like that could cause a problem? Yes, there is a problem. You can't have the argument be negative. And I get some people say, but you're going to put it to the fourth. No, you're not. Because that fourth could be in front. Remember that deal? You can move the power to the front. So you can't let this part be negative. So that means after all that work and figuring out that there is a negative answer, you got to rule it out. Holy cow, that got complicated. But all it was little exceptions. That happens in life. There are exceptions. And you got to know, like, the detailed rules. Taxes are kind of like that. It's really complicated. It isn't just like pay 10% of your money in taxes. Oh my gosh, it's so complicated. You cannot have to pay taxes if you put the money in this thing. And then if you put the money in that thing, but you make too much income, then you can't put quite as much money in that thing. And so then you still have to pay taxes on part of it. And life is complicated. And math rewards careful people. So I'll help you go through some of these, and we'll talk about the weird little tricks that you got to watch out for. Okay, on that one on the left, what's true about the inside? This is the argument. Do you get that that has to stay positive? Do you also remember that if I were to graph this thing, that's where the asymptote would be? Do you remember that too? Okay. All right, so now, if I'm going to solve this, I didn't really talk about this too much yesterday, but I'm going to remind you, PEMDAS is the thing. But when you're solving equations, you start with add or subtract. A lot of people think, there's a -3 here, so then I should add 3 to both sides. Nope. It's stuck inside a parenthesis. It's trapped in that parentheses. So you cannot do any add or subtracts on this one. But could you do a multiply or divide on this one? Yeah, you're going to divide by 7. Everybody start with that and simplify it down. And whenever you get stuck, it's time to rewrite. As a person I don't think is with me right now, this lesson will be short. Come back. Try this with me or you're going to get lost. Log base 7 of x plus 3 is, I got to simplify that now, right? That's where I am in this problem. This is equal to 2. So now I got log base 7 of x minus 3 is 2. Whenever you get stuck and you're like, I can't think of adding or subtracting anything else to like simplify it more, it's probably because your log is alone then. My log is alone. There's nothing in front of it. There's nothing added or subtracted from it at the end. Then it's time for the rewrite. 7 to the second equals x minus 3. Now, a rule about parentheses. When the parentheses, when there's nothing you can do in them, like I can't actually subtract x minus 3. I don't know what x is, so I can't do that. And there's nothing being multiplied into it, then the parentheses can be erased. Sometimes they can be erased. There, I can erase those. Why? Because there's nothing I can do in them, and there's nothing to distribute into the parentheses, then the parentheses can be dropped. All right, and of course 7 squared is 49. And all of a sudden, this one isn't that bad. I'm going to add 3 to both sides. And I'm just going to make sure that I don't end up with some weird, answer to my original. If I go put the 52 back in here, is that going to cause my function to not work? Like, somehow cause me to have a negative argument or a negative base? My 52 doesn't cause a problem. So then that's it. Yes? Yeah, when I went from the red writing to the blue writing, yeah, that's kind of the beauty of exponentials and logs, is that when you have a log, you can get rid of it when you rewrite it this way. that to the that equaled that. All of a sudden, that's an exponential. It doesn't have a log anymore. All right, let's look at this other one. And I helped with that last one. That should mean you should know what to do if you were following on that last one. Try to do the 5 log space 6 part. The second half of the problems. Spencer, how do you start? Hint? Close. It's something like that, but you start with any add or subtract that you can do. There you go. Keep going from there. Actually, you, not, I didn't mean necessarily you. I mean everybody. Everybody keep going from there. I made it a little easier. Now I got to do the next step. Riker, what's the next step? Divide by 5. Or multiply by 1/5 would do the same thing. It would knock that out. And then 10 divided by 5 is 2. So then I got log base 6, 8 minus x. And then you're always going to get stuck at some point like this. And that's the time for the rewrite. When I say rewrite, I mean it is a log now, and the answer needs to not be a log. So we rewrite it out of logs, the circle of logs. 6 to the second equals 8 minus x. And you remember that deal where if there's nothing I can do in the parentheses, and there's nothing happening to the parentheses, like no distributes happening on the outside there, then I can erase those parentheses. Yes?
If your argument is negative, does the thing just not work then?
Yeah, if I get an answer that causes this to become negative, then that answer is not a real answer. That's called an extraneous answer. So 36 equals 8 minus x. And then I'm going to subtract 8 from both sides. A lot of people get confused on that. They see this negative and they think, aren't you supposed to add? Nope, that negative stays on the x. This 8 is positive. X equals negative 28. Now, does that automatically mean that it's out? No. I go stick it in my equation, though, in the original equation, and I see if negative 28 would be okay up there. Let's see. If I put in a negative 28 in exactly where the x was, then it'll have 2 negatives, and that's positive, and therefore it's okay. Really common for people to go, didn't you just say that it can't be negative? Well, I said that the base can't be negative and the argument can't be negative. And so this negative number actually works because you got 2 negatives. So this is the correct answer. It is not extraneous. Just making sure I didn't make a dumb mistake in there. Who else got a 28 without me? Okay, good. All right. So don't forget that these both have to be positive, but also your base here, I hate that they used A and B because B seems like it should be the base. But anyway, this is the base. That can't be 1. You remember how base of 1s don't exist? Okay. All right, next slide. Slide 5. We're getting close to done here, everybody. Now this is that kind where we're going to get a quadratic at the end. Quadratics are good. That means you can use the quadratic formula or you can factor it. We almost always make them factor in here. So whenever you see a problem that's got like logs on both sides, it's pretty likely it's going to all turn out to be a quadratic. But we'll see. We'll see. So step number 1 doesn't have bases. I'm going to go just right in, and that's what I would do too. I wouldn't rewrite the whole thing. I'd just squeeze in a little base 10 here because that matters, right? Base 10 here, base 10 here. Next thing I would do is put away the 2. Do you know where this can go? Up on the 5. Why did you do that, though? Because I want to combine these two logs, and I can't until they're a plain log. A plain log and a plain log, and then I can condense them. Do you remember that from before? Do you get they're both logs? This one used to be 2 log, but I moved the 2. So they're both logs. So they can be combined, condensed into 1 log. And I said something early on this year. I said, if you can factor it, you should. And in this unit, I said, if you can combine the logs, you should. Okay, so I'm going to combine them together. And now I've got, since this was a plus, I'm going to use a times, and it'll be x times, and then that 5 squared is really 25. So I may as well call it 25x. I mean, x25 isn't like, it's the same thing, but 25x is how we say that. Equals log base 10 of x plus 6. All right, and did you know that if these are the same, then these have to be the same? That has to equal that. Now, a way that kids like to think of this is that the logs cancel. Technically, the logs don't cancel, but it acts like that because 25x will be x plus 6. And from there, it's super easy to solve. See, this part here is equal to this part here. And then from there, you're down to just like a couple steps left and you'll be done. So what just happened there? I had to know how to condense. I had to know that when the logs are the same base that I can take them out and I can look at this equaling this. Remember, technically, these are not canceling. I'm just telling you that because I'm a math teacher, but it's like they cancel. And this equals this. So now I just have to subtract x from both sides, and I got 24x equals 6. Divide by 24, divide by 24. And if you haven't caught on to my obsession with factoring, this is 6 times 1 over 6 times 4. And look, factoring saves the day again. The answer is 1/4. Now, if I should really check to make sure that doesn't make anything die in my equation up here, is 1/4 going to be okay there? Yeah. Is 1/4 going to be okay there? Yep, it is. So there we go. Now, is there any part of that where you feel like I messed up or you don't understand why this or that happened? Because you know I do make mistakes sometimes. Which part don't you like?
No, I don't know if you made a mistake. I just don't know. When you subtract x from both sides, why don't you, what happens to the x?
If you have 25 xylophones and you take away 1 xylophone,
Oh, okay, 24, yeah.
24 xylophones. That's okay. Happens all the time. It's just a little algebra thing. So, yep, I did it right, I think. All right. Next page, we're getting close to done. We're on page 6 out of 7. All right. This one. Hint, it's going to come out to a quadratic, but you'll have to multiply it all out, set it equal to 0, and factor it. This is the kind that'll separate the A's from the B's, because most people will know how to squish these two together, condensing. Most people will be able to take out the log, because there's logs on both sides, and then they'll disappear. But it'll be who can do their algebra. Can you set it equal to 0? Can you factor it? Can you solve it? And then who remembers to check to see if one of the answers is extraneous, because I think it will be. All right, so this will separate my A's and my B's. And for some people, the difference will be between a B and a C. So can you do it? Yeah, you can. It's just whether or not you can grind out the algebra. I'll pause while I give this a shot. Just to make sure you're getting started right. This gets put together as 1 log with this times this. And this already is 1 log. And they have the same base. So I'm okay with, as long as you know these aren't really canceling, with you just ignoring them. And therefore this is equal to that. But it's complicated, so I guess what I think I heard Mr. Server say was set it equal to 0. So I would multiply this out. And then I would subtract 16 from both sides. Simplify it down, and if you can factor it, you should. Who was doing it right up to there? All right. Those are some of the kids with the stronger algebra. So much of this isn't even precalc. So much of this is just algebra after the first couple steps. Once you got it to the factoring part, would you please compare with the kid next to you? And what did you get for the factors? This would be a good way to say it.
Yeah, that's fine.
Take your time on grading this, but give this a quick grade off of the key and see how you did. All right, so I heard some kids comparing, but I know a lot of people weren't there yet. It was x squared plus 2x, and then these two together make minus 24 equals 0. And then 24 is nasty because there's like so many ways to make a 24. But when I see a 2 here, I'm thinking x and x. Oh wait, I gotta first figure out signs. Yeah, that's a plus and a minus. When there's a 2 there, I want something that has a difference of 2. 6 and 4. 6 and 4. So x equals -6 and x equals 4. You see how factoring happened again? And I hope you know that one of these is suspect. I don't know yet because I haven't looked at the original problem, but I betcha, yup, that negative one, it's going to make the argument negative here. And it would also make that negative. But it doesn't even matter. If it fails in one of the two arguments, it fails. It failed, it's out. Cool. There you go. The answer was just 4 then. But the way you have to answer is you have to show me both answers and then show me which one doesn't work. And ideally, I probably wouldn't mark it wrong for this, but you're supposed to say EXT. Get used to that on a AP test for calculus or in college. They would expect you to call it an extraneous answer, not just cross it off. Identify it as an extraneous solution. All right, cool. I need to know, be honest, how many of you could follow that and understand? Okay, good. Let's go on to this. The last slide, the last page, doesn't have bases, makes it a little more complicated. Do this last problem. Everybody, do this last problem. And then we're off to the homework and you got a whole bunch of work time. Did you guys remember to put the 3 away? Because Because otherwise, when you drop out the log, where would that 3 even be? Like, if when you cancel out the logs later, that 3 has to be up on the 2, otherwise it'd be lost in Never Never Land. So I'm combining these. I got log base 10 of that and that, x minus 2 and x plus 5, and then I got log base 10 of 2 to the third. Then these technically aren't canceling, but we can ignore them. And now this will be x squared minus 2x plus 5x minus 10 equals 2 to the third is really 8. Subtract 8 from both sides and clean it all up. X squared plus 3x minus 10 and minus 8 makes minus 18 equals 0. In the real world, does everything factor? No. In the real world, a lot of times the numbers are really gross. These equations actually can be used in the real world, like for figuring out exactly what curve you would want to put in the car. And when you get your answer, it's always a decimal. So you'd use the quadratic formula. But we make them factor because we are obsessed with, and it's not just me, because the people who make the tests, we always make it so it factors. Because we think that's huge. Happens in calculus too. You got to know how to factor all the time. Okay, so then we go plus and minus. And then this is plus 6 and minus 3. I'm pretty sure, double checking, outside, inside makes total of 3x, yay. And then I get x equals negative 6 and x equals 3, and I'm suspicious of this one. So I'm going to double check this one. Negative 6 would cause a problem in here and in there, and if it causes a problem either place, it's out. And then I'm just going to check my 3 in here and in here, and the 3 works in both places. So, bottom line, I think it's 3. Anybody else get 3? Cool. There you go. You see how so much math just came together there? Solving equations, knowing how to factor, knowing how to check for extraneous solutions, knowing what a log was, knowing about the base of a log. The only thing we didn't do in that whole problem is rewrite the log, but we did that in the other problems today, so don't forget that part. If you have something like this and you're stuck, think rewrite. And the log will be gone. And this would just be 3 squared is 9. 9 equals x plus 5, and all of a sudden it's super easy. Okay, that is all I have for you for today. The assignment is the evens. I think you'll find it to be refreshingly easy. Hope to near the end of the hour share something else kind of cool with you, but that is it for the lesson.